Hi everyone, here's the practice test that we've been waiting for on the test 3. First one says show that 3 minus 4x and that f of x equals 3 minus 4x and g of x equals 3 minus x over 4 are inverse functions algebraically and graphically. Explain why each method is evidence that f of x and g of x are inverses. Well, the first thing I want to go is algebraically. Algebraically, if f of g of x is equal to the same thing as g of f of x, and they both, the thing that they are equal to is x, then that is proof algebraically that these are inverse functions. Alright, well let's start with the f of g of x. F of g of x is f of 3 minus x over 4. And that is plugged in to the f function, which is 3 minus 4. Take the x out, put 3 minus x over 4 in its place. And then we'll simplify here a little bit. I'm seeing the 4's canceling out. And when I remove these parentheses, I got 3 minus 3. I'm not going to take those parentheses out. I'm going to put 3 minus x, which is 3 minus 3, and a negative is plus x. Those cancel. That is x. So we got one place where it's saying it's x. So far, so good. Now let's go for g of f of x. And that is, let me kind of section this off here a little bit. G of 3 minus 4x. And then when I put 3 minus 4x in place of x up here, that is equaling 3 minus 4x over 4. And get rid of the parentheses there. I'm looking at 3 minus 3 plus 4x over 4. 3 minus 3 is 0. 0 plus 4x is 4x. 4x divided by 4 is x. Alright, we got x both times. And since this worked out, algebraically, we've shown their inverses. Now, I want to actually make the graph of these. If I'm going to graph f of x equals 3 minus 4x, let's see. I'm going to use y-intercept. Y-intercept's 3. The slope is negative 4. So I'm going to go down 1, 2, 3, 4 over 1. Do that again. 1, 2, 3, 4, and over 1. Maybe one more time. 1, 2, 3, 4, 1. If I go up 1, 2, 3, 4, and right 1, there's another point. So I want to carefully draw a line through there. I say carefully. It's the best I can do, guys. And I'm going to graph g of x equals 3 minus x over 4. Let me just put some values in for x and graph. If x is 0, I'm going to make a little table up right here. Oh, okay. Make up my mind. Here's x, here's y. If x is 0, 3 minus 0 is 3, so y is 3/4. If x is 3, I like that, 3 minus 3 is 0. 0 over 4 is 0. Let's look at those two first. 0 3/4, like right there. 3 0 is right here. I think I can go like that. And 1 and 1, 2, 3, 4. And go up 1 from here. Go up 1, 1, 2, 3, 4 from here. And then draw that line carefully. Right there. Okay, now the next thing I want to do to see, I've got the two lines on there. I'm going to graph y equals x. And if it looks like this is reflecting over that, then we're in business as far as showing it graphically. Y equals x just cuts the first quadrant right in half. Trying to see it. There we go. And the third quadrant is cut in half here. Okay, now here's my line. It does appear to me, if I draw that to that, it looks like we are reflecting from one line over the y equals x line. Looks like pretty conclusively that that's happening. So there's the graphic. And I'm just going to write the comment that it reflects okay. I'm going to have to get a pencil. Gravity is preventing me from writing like I want to write, so that's not necessary with a pencil. Reflects over y equals x. F and G do. All right. Now, 2, 3, and 4. It says find the inverse functions of the following. And this is where I would encourage you. Let me also point out, if you do this, like what I'm about to do, if you do that up here and you get one from the other, I'll take that as algebraic proof as well. So I want to keep that as an option for you. Y equals 1/2 x minus 5. I put y in place of f of x because it's a little easier just to kind of switch those two around. This is where I start the inverse part. X equals, forgot the 1/2, x equals 1/2 y minus 5. Now I'm going to solve this for y. And when I solve it for y, the first thing I'm going to do is add 5 to both sides. Let me come up here. And I've got x plus 5 here equals 1/2 y. And then I'm going to multiply by 2 on both sides. Keep that in parentheses. And I see 2 times x plus 5. You can distribute if you want is equal to y, or you can leave it factored. But there is what I'm going to call the, whoops. Let me go to inverse notation now. 2 times x plus 5. So the inverse function, that's the f negative 1 of x equals 2 times x plus 5. Alright, now when I do it for number 3, I got y equals the square root of x minus 10. And then the inverse part is x equals the square root of y minus 10. And I'm going to square both sides. So I have x squared, the square and square root are canceling out, equals y minus 10. I'm going to add 10 to both sides. And I got x squared plus 10 equals y. The inverse function notation, instead of y, I'm going to write f negative 1 of x equals x squared plus 10. Alright. There's my final answer there. There's my final answer there. Now, h of x, I want to find the inverse of h. So I'll use the y equals 4x cubed minus 11. I'll switch and got x equals 4y cubed minus 11. And I'm going to add 11 to both sides first. I start furthest from the y and work my way toward it. So that's x plus 11 equals 4y cubed. Then I'm dividing by 4. I'll bring that up here. X plus 11 over 4 is equal to y cubed. And then to uncube, I'm going to take the cube root of both sides, and I'm going to go with my function notation now and write h inverse, the inverse of h of x, is equal to this right here. That's how we got y by itself there. The cube root of x plus 11 over 4. I just noticed when I did this should be a g here. Alrighty. Now, the next thing is, I think we get into the scatter plot work a little bit. And I've already drawn the scatter plot there. I scaled this by 60, skipped 1, 65, and so on, went by 5s there. What I'd like to do is show how to enter the data on a graphing calculator. Try to get to a good place where it can be seen. This is a little more difficult than I was anticipating. But if you enter your data, first go stat. I'm really hoping you're seeing this. Stat, edit, and then put in L1, I'm going to put the x coordinates, 75, 82, 90, 65, 71, 88, 93, 69, 80, 85, that's it, and then I'll come over here and put in the 2.3, the 3.0, 3.6, 2.0, 2.1, 3.5, 3.9, 2.0, 2.8, and 3.3. Hopefully that's all matching up. It looks like it is. Okay, what we do here is we're going to hit Stat. I'm going to go over to Calc, and I'm going to do the linear regression, AX plus B. And I do have the diagnostics on, and you can see I got A is 0.074, B is negative 3.084 is where I went, and then R I used 0.986. And the rest of it just comes off of that. The relationship is strong. That 0.986, and that kind of answers this down here too, is very close to 1, and that shows a strong positive relationship. The equation we just looked at, the y equals ax plus b. A was 0.074, b was negative 3.084. Using the least squares regression line, this is the equation for it, to predict a freshman GPA of a student whose interest score was 77. Plug 77 in for x, and then I didn't do that calculation. 0.074 times 77 minus 77, that'd be right around here. I forgot to do the calculation. If I I was to make a guess, I would guess around the 2 point. Now you can do that calculation. I'll let you do that on your own. But I would guess around a 2.7 or something, just looking at my graph. I did take a little bit of time to just plot a couple of points that would be on this line, like when x is 60, what's y? When x is 95, what's y? It's around a 4 right then. So I did take time to put those 2 points on and make that line carefully. All right. Next. So the next thing is describe how the graph of these two equations, each one, is related to y equals x squared. All right, well, the vertex here is at 0, 0. And this opens up. That's what y equals x squared does, and that's our standard. This one would be the same size, but its vertex would be at 4, 2. Y equals ax minus h squared. So what's after the minus is the x coordinate of the vertex, and what's out here is the y coordinate of the vertex. So the vertex is at 4, 2, and this one would open up. There is no dilation or anything. It's the same size. This one, on the other hand, we can get its vertex is -2, -1. Just change those. And it would be actually reflected. Well, I'm just going to write that it opens down. This one opens down due to the negative coefficient out here. It opens down. It is also wider by a factor of 3. I'll just write it's wider than the y equals x squared parabola. When that number is between 0 and 1, or the absolute value of that number is between 0 and 1, it's going to be wide. If it's bigger than 1, that the parabola would get narrower. All right, numbers 12 and 13. It says rewrite f of x equals a times x minus h squared plus k form. And then we'll describe the graph after we do that. This is going to require completing the square. And f of x equals, I'm going to put x squared plus 6x plus something. We'll figure that out to complete the square. Minus the 20. Keep the number out here. And then let's subtract. Whatever we add here, let's subtract here. Give myself a boundary here. Now, what do we add? We want to complete the square. So we take the middle term coefficient, that's the 6, divide it by 2, and we square that. And that's 3 squared, which is 9. So I'm going to add 9 here. I can't just add 9 there without subtracting 9 there. I've got to keep it equal. So I got my f of x equals x plus 3 squared, negative 20, negative 9 is negative 29. This one, now that I see this, we'll say it opens up and has a vertex at negative 3, negative 29. Okay. Looks good to me. This looks good. I'm wondering about my answer sheet I gave you guys that I posted, if that's agreeing there. I wonder if I accidentally added 9, but we'll see. I'll take a look at that later. The clock's running, the camera's running right now, so I'm going to keep going. Now, when you have a problem like this, that negative 2, I'll write the f of x later, needs factored out of this term, out here, and out of this term. Negative 7 divided by negative 2 is positive 3.5. And then Then I'm going to complete that square. I'm going to add 2.25, and I'm actually got to, since this is negative, I'm going to add 2 times whatever that is. So plus 2.25, if I had more room, I would write it over here, but I ran out of the room on that paper. So I am going to take the 3.5 divided by 2, and I'm going to square that. Now I know that's 1.75 squared. I do want to check real quick what 1.75 squared is. $3.0625 here, 3.0625 here. I think that's 6.125 when you get all said and done. So here, f of x equals x plus 1.75 squared. And this is 2.25. Let me just do that. 2.25 here and 6.125 here. That looks like 8.375 here. All right. Oh, don't forget that -2. That -2's got to come down. So the vertex, this one opens down because of the -2. Its vertex is at -1.75, 8.375. Okay, number 14. Y equals a times x minus h squared plus k. And the vertex gives h and k. Well, let me plug those in. That's x minus 4 squared plus 1. The a value is what we need to find. We're going to have to use what we know a point on the parabola to be, x and y. So I'm going to put the -7 where y is, equals a, put the 6 where the x is, and I got the -4 and squared and plus 1. So -7 equals 2 to the second power, that's 4. So that's 4a plus 1. This part right here is 4, just put it in front of the a. Subtract 1, subtract 1. -8 equals 4a. Divide by 4. And I'm getting a equaling -2. I'll put that up here. My final answer, I'm going to write y equals -2. I did all this work so I could find what that value would go right here. Equals x minus 4 squared plus 1. All right. Last page. Okay, I'm going to use the calculator to really do this one. I don't know how much of that you can see. Let me bring it down here a little bit. So I'm going to put the formula in the calculator. Let me see if I can find a good spot to put this. Hit the y equals negative, I need to use parentheses here, 16 divided by 2025, close those, x squared plus, now 9 divided by 5 is 1.8, 1.8x, you can just put 9 divided by 5 if you want, x and 3 divided by 2 is 1.5. Alright, now if I go to graph that, I'm not going to see a whole lot of that. So what I want to do is I want to change the window, because we're talking about a punter in a football field, and we're talking about in feet. Horizontal distance. Let's go 0 at the starting point for X men. I'm going to go 300 feet. That's the length of a football field. And I'll mark them by 10s. Okay. Football fields are marked in 10 yards, not 10 feet, but that's all right. I'm going to start at 0 here. The Y max, how high do I think? I'm going to try 100 feet. I'm going to look at the graph. All right, that looks a lot better, except I don't see the peak. So I'm going to increase the Y max sum to, let's say, 120 feet. And I'll change the scale to 10s too, so it's not so cramped. All right, good, I'm seeing it. Now I'm going to answer these questions. How high is the football when it is punted? And that's when X is 0, it's 0. So these two terms fall out, and that's 3 over 2. I think it hits the punter's foot 1.5 feet above the ground. And that's at 0. That's when he's standing where he punted. What is the maximum height of the football? So I'm going to hit Calc. I hope you guys are seeing this. But that's the second and trace button. And I'm going to go for the Calc. That's the maximum. And I want to be on the left side of this vertex. Hit enter. And then I want to be on the right side of the vertex. And I'm just scrolling around here a little bit. Hit enter. And then when it says guess, I'll hit enter again. And that gives me X is 113.90628. Y is 104.0. And Y is the height. X is how far down the field we are. Y is the height. So I'm going to put the height in as about 104 feet. And then how far be over here? How far from where the punter does the football first hit the ground? So over here, when we hit the ground, when Y is 0, and there I'm going to use, not stat, I'm going to use second calc, number 2. I'm going to look for that 0. And on the left side of the 0, so while we're still above ground, and I'm looking at the Y values here, I'm at 48 feet now, 20, 14, 9 feet. I'm going to hit enter, and then I'm going to look at the Y values. I can't quite see on the graph because I didn't scale it. Now I'm at negative values on the Y, so I'm on the other side of the ground there, so to speak. And then the guess, at the 0, it looks like 228.6 feet. All right, there's that. Hopefully some of you get a chance to look at this if I made it correctly. I'll see you Monday.